All right, so I have another reaction I want to visualize with you all. This time we're going to have a polyatomic ion. We have phosphate, PO43 minus. So whenever we see PO4, we're going to be calling that phosphate. That's when you have a phosphorus center with four outer oxygen atoms. We'll be calling that a phosphate. It's a polyatomic ion. So you'll notice we don't mess with the polyatomic ion in most chemical reactions, especially in this double displacement sort of context. If you've never heard double displacement, don't worry about it for today. Just notice that the PO4 stays the same on both sides. We don't mess with that chemical formula. We treat it as like a single entity. Okay. So here's a reaction. We have calcium chloride. I'll be using orange for calcium. We have 2 chlorines. Sodium phosphate, we have 3 sodiums, and we have 1 phosphate. We don't have 4, we have one phosphate. Okay. 1 phosphate has 1 phosphorus and 4 oxygens. That single thing, 1P and O4, is that whole thing we call a phosphate. We have 1 phosphate. Okay. By the time this reaction is done, we will have 3 calcium phosphates. Sorry, I meant to say 1 calcium phosphate. 1 calcium phosphate has 3 calciums and 2 phosphates. It's getting very crowded on this sheet. Okay, and then we're going to end up with at least 1 sodium chloride. Okay. Like so. Okay, so let's go ahead and balance this reaction. So if we're ending with 3 calciums, we must start with 3 calciums. Calciums come in packages of 1 calcium for every 2 chlorines. And we'll have to build 3 of these calcium chlorides in order to have the 3 calciums needed on both sides. Okay, let's do phosphate next. If we're ending with 2 phosphates, that means we need to start with 2 phosphates. This is going to get very, very crowded. Okay, so let's get second phosphate. Sodium phosphate right there. Okay. All right, so 3 calcium chlorides, 2 sodium phosphates. We have 1 calcium phosphate, and we need to figure out how many sodium chlorides we need to end up with so that it's balanced. So we have 6 sodiums and 6 chlorines on the left side, the reactant side. So on the product side, we must also end with 6 calciums and 6 chlorines. Okay, so they come in a 1-to-1 ratio, sodium and chlorine. So there's 2, 3, 4, 5, and 6. Okay, let's see if this crazy big reaction balanced. Oh, there's number 6. All right, 3 calciums, 2 phosphates, 2 phosphates, 6 sodiums, 6 sodiums, 6 chlorines, 6 chlorines. So this reaction is balanced. Notice how with polyatomic ions, you didn't see me counting oxygens or phosphoruses. It's easier to count with the entire polyatomic ion. Instead of saying 2 phosphoruses each side, 8 oxygens each side, I just count phosphates. So don't fight the polyatomic ions. Learn them, and it makes your life easier. Eventually. You may not agree with me today. All right. So, yeah, we had 3 of these. We had 2 of those. We had just 1 of those. Again, some homework programs have you write that 1, but most of the time in chemistry we don't write that 1. And we had 6 sodium chlorides. All right, hope this helps, and let me know if you have any other ideas. Thanks. Take care.